February 23rd, 1944, the frozen mud of the Anzio beachhead. Through the morning fog, SS-Hauptsturmführer Klaus Dietrich watched another American Sherman crawl into position along the tree line. His Tiger tank sat hull down behind a farmhouse wall, its 88mm gun already ranged for the kill. 800 yards separated predator from prey. Dietrich had destroyed 17 American tanks in the previous month, all Shermans, all with the pathetic 75mm gun that German intelligence had thoroughly analyzed and dismissed. The reports were unambiguous. At ranges beyond 500 yards, the American 75mm M3 gun could not penetrate Tiger frontal armor. The mathematics were simple. The Sherman's armor-piercing round carried insufficient velocity to defeat 100mm of face-hardened steel angled at 12 degrees. German tank doctrine was built on this certainty. But this particular Sherman carried ammunition that German intelligence had never seen. Rounds developed in secrecy at Aberdeen Proving Ground in Maryland. Projectiles that violated every assumption about what a medium-velocity gun could achieve against heavy armor. The American crew had been issued strict orders: fire only when certain of a killing shot, recover all spent casings, never discuss the ammunition with anyone outside the immediate chain of command. Staff Sergeant Michael Horvath peered through his gunner's sight at the Tiger's silhouette. His loader had already positioned the special round, identifiable by its distinctive silver band around the projectile base, the round that wasn't supposed to exist, the penetrator that German metallurgists would have declared impossible if they had known of its development. In that frozen moment, before Horvath pulled the trigger, decades of conventional wisdom about tank gunnery were about to shatter against the reality of American industrial chemistry applied to battlefield problems that European theorists had considered solved. The winter of 1942 brought a brutal awakening to American armored forces deploying to North Africa. The M4 Sherman tank, pride of Detroit's assembly lines, mounted a 75mm M3 gun that represented the apex of American tank weapon development when production began in 1941. The gun fired a 17-pound armor-piercing projectile at approximately 2,000 feet per second. Against the German tanks encountered in early North African fighting, the Panzer III and Panzer IV, this performance proved adequate at combat ranges. But intelligence reports filtering back from British units fighting in the Western Desert carried disturbing information about new German heavy tanks. The WWII, mounting an 88mm gun derived from the legendary Flak 18 anti-aircraft weapon, had appeared in Tunisia in December 1942. British tank crews reported engagement, ranges exceeding 2,000 yards, where German guns could penetrate any Allied armor while remaining invulnerable to return fire. Lieutenant Colonel Leslie McNair stood in the testing bays at Aberdeen Proving Ground in Maryland, watching technicians position a captured Tiger tank's frontal armor plate for ballistic testing. The plate measured 100mm thick, manufactured from face-hardened steel that placed the hardest material on the outer surface, while maintaining softer, more ductile steel beneath to prevent catastrophic cracking. The standard American 75mm armor-piercing round, designated M61, consisted of a solid steel projectile with a hardened cap designed to bite into enemy armor and prevent deflection. The cap worked effectively against homogeneous armor plate, but struggled against the face-hardened steel that German factories had perfected during 2 decades of metallurgical development. McNair's test crews fired M61 rounds at the Tiger armor from progressively closer ranges. At 1,000 yards, the projectiles shattered against the hardened face without penetration. At 800 yards, some rounds achieved partial penetration before the projectile body fractured. At 500 yards, penetration became possible but unreliable. The results confirmed what British combat reports had indicated. The standard American tank gun could not reliably defeat Tiger armor at any tactically useful range. The problem extended beyond simple velocity calculations. Face-hardened armor defeated penetrating projectiles through a two-stage process. The hardened outer face shattered the penetrator's tip, while the softer backing absorbed the projectile's remaining energy. German metallurgists had optimized this system specifically to defeat the monoblock steel projectiles that Allied forces used throughout the early war period. Major Edwin Studebaker of the Ordnance Department's Ballistics Research Division understood that solving the penetration problem required abandoning conventional assumptions about armor-piercing projectile design. The existing M61 round used the same basic technology that had characterized tank ammunition since the First World War. A solid steel slug with a hardened cap, relying on mass and velocity to punch through enemy armor. Studebaker had spent 18 months studying captured German ammunition, examining projectiles recovered from destroyed Allied tanks, and analyzing the metallurgical principles that made German guns so devastatingly effective. German armor-piercing rounds used a sub-caliber tungsten carbide core surrounded by a lighter metal jacket. When the projectile struck armor, the jacket stripped away, leaving the dense tungsten core to penetrate using concentrated energy applied to a smaller surface area. The principle was elegant, but presented enormous manufacturing challenges. Tungsten carbide, one of the hardest substances available to industrial production, required specialized machining and assembly techniques. The material was scarce, expensive, and difficult to work with existing American manufacturing equipment, but the performance advantages were undeniable. German sub-caliber rounds achieved penetration that seemed impossible for their relatively modest gun velocities. American metallurgists had been experimenting with similar concepts since early 1942, but struggled with manufacturing consistency. Early test projectiles shattered on impact or tumbled in flight, producing wildly inconsistent results. The breakthrough came from an unexpected source. Ballistics researchers examining shattered test projectiles discovered that certain tungsten carbide formulations maintained structural integrity under impact stress that would fracture other compositions. By summer 1943, Aberdeen Proving Ground had developed a functioning prototype. The projectile, designated T-45, consisted of a tungsten carbide core measuring approximately 1 inch in diameter and 4 inches long, surrounded by a lightweight aluminum jacket that brought the overall diameter to 75 millimeters to match the gun bore. The core weighed approximately 4 pounds, compared to the 17-pound mass of the complete M61 projectile. The physics were counterintuitive. A lighter projectile, fired from the same gun, achieved higher velocity due to reduced mass. The tungsten core's extreme hardness allowed it to maintain structural integrity during armor penetration where steel projectiles would fracture. The smaller diameter concentrated impact energy onto a reduced surface area, increasing pressure at the point of contact with enemy armor. Initial testing revealed dramatic improvements in penetration performance. T-45 rounds, fired from a standard 75mm M3 gun, penetrated 100mm of face-hardened armor at ranges exceeding 1,000 yards. The same gun that had been dismissed as ineffective against Tiger armor could now defeat it at ranges where German crews assumed themselves invulnerable to American fire. But the tungsten carbide core technology carried significant limitations that would affect its tactical deployment. Each T-45 round required approximately 1 pound of tungsten carbide, a material already in critical shortage for machine tool manufacturing and other essential war production. American tungsten supplies came primarily from Chinese and South American sources, transported across submarine-infested oceans to reach domestic processing facilities. The Ordnance Department calculated that unlimited production of tungsten-cored ammunition would exhaust American tungsten reserves within 6 months, while crippling machine tool production essential for maintaining overall war manufacturing capacity. The scarcity problem demanded strict allocation. Tungsten-cored rounds could be issued only in limited quantities to units most likely to encounter German heavy armor. Lieutenant Colonel McNair received authorization in September 1943 to begin limited production of what was now designated the M93 hypervelocity armor-piercing round. Initial production runs would provide approximately 10 rounds per tank, for armored divisions deploying to the European theater. Tank crews would receive explicit instructions: fire M93 ammunition only against heavy armor targets that could not be defeated with standard rounds. Recover spent casings when tactically feasible. Never discuss the ammunition's existence or performance with personnel outside the immediate unit. The security measures reflected genuine concern about German intelligence capabilities. If German forces learned that American 75mm guns could penetrate Tiger armor using special ammunition, they would adapt their tactics to prevent American tanks from achieving effective firing positions. The element of surprise, combined with German assumptions about American gun performance, represented a tactical advantage that had to be preserved through operational security. Training crews to employ M93 ammunition effectively presented challenges that extended beyond simple gunnery instruction. Tank gunners had to learn to identify targets that justified expenditure of scarce tungsten-cored rounds while conserving ammunition for situations where its superior penetration was essential. The distinction between appropriate and inappropriate targets for M93 rounds required judgment that came only with combat experience. Sergeant First Class Robert Hayes of the 1st Armored Division received his first M93 ammunition issue in November 1943 during pre-deployment training at Fort Knox. The rounds arrived in unmarked wooden crates, distinguished from standard ammunition only by a silver band painted around each projectile's base. Hayes and his crew received a 1-hour briefing on employment doctrine. Engage Tigers and Panthers at maximum effective range. Fire M93 rounds, first to achieve penetration, then switch to high explosive against softer targets. Never leave spent M93 casings on the battlefield where German intelligence could recover them. The ammunition's existence remained classified at the highest levels. Even divisional commanders received only vague briefings about new armor-piercing capabilities without detailed information about the technology involved. The security apparatus surrounding M93 production and deployment created a situation where thousands of American tank crewmen possessed weapons capabilities their own officers didn't fully understand. As 1943 ended and American armored divisions prepared for deployment to the expanding European theater, the gap between German intelligence estimates and American tactical capabilities had grown to proportions that would prove decisive in the battles ahead. German tank doctrine remained frozen around the assumption that American 75mm guns posed no threat to heavy armor beyond 500 yards. American crews carried ammunition that could defeat that armor at ranges approaching 1,000 yards. The quiet revolution in American armor-piercing technology had succeeded not through dramatic announcements or public demonstrations, but through careful industrial development, combined with operational security that kept German intelligence unaware that American tank guns had evolved far beyond what Wehrmacht tacticians assumed possible. The frozen beachhead at Anzio became a killing ground where German and American armor fought at ranges that maximized German advantages in gun performance and armor protection. Tiger tanks, positioned in hull-down defensive positions, could engage American Shermans at distances exceeding 1,500 yards, well beyond the effective range of standard 75mm ammunition. American tank commanders learned to avoid open approaches where German gunners could employ their range advantage with devastating effect. Staff Sergeant Michael Horvath arrived at Anzio in February 1944, carrying 10 M93 rounds carefully secured in his Sherman's ammunition storage. His crew had been briefed on the special ammunition during their Atlantic crossing, but had never fired it in combat. The silver-banded rounds remained segregated from standard ammunition, positioned where the loader could identify them instantly when the gunner called for hypervelocity. The morning of February 23rd brought reports of Tiger tanks supporting German infantry attacks against American positions near the Mussolini Canal. Horvath's platoon received orders to provide armored support for infantry units holding a tree line that commanded approaches to the beachhead perimeter. The tactical situation offered poor fields of fire and limited maneuver space, exactly the conditions where American armor typically suffered against German heavy tanks. Horvath positioned his Sherman in a concealed firing location that provided clear observation across approximately 800 yards of open ground. The range fell within the effective envelope for M93 ammunition, but exceeded the distance where standard rounds could reliably penetrate Tiger armor. His orders were explicit. Wait for Tiger targets. Fire M93 rounds exclusively. Conserve ammunition for situations where penetration was essential for survival. The German attack developed with the methodical precision that characterized Wehrmacht tactical doctrine. Tiger tanks advanced in overwatch formation, each vehicle covering its partner's movement while maintaining firing positions that maximized armor protection. The lead Tiger emerged from fog at approximately 900 yards, its distinctive silhouette immediately recognizable to American crews who had learned to fear the massive tank's 88mm gun. SS-Hauptsturmführer Klaus Dietrich commanded the lead Tiger, scanning for American positions through his commander's cupola. His intelligence briefings had been explicit about American tank capabilities. Sherman 75mm guns posed no threat beyond 500 yards. German tactical doctrine called for engaging American armor at maximum range, destroying targets before they could close to distances where their guns became effective. Dietrich identified Horvath's Sherman at 800 yards, partially concealed among trees but visible enough for accurate fire. The range provided comfortable margins for Tiger gunnery, while keeping the American tank well beyond its effective engagement distance. Dietrich gave the order to fire, expecting the familiar sequence of penetration, ammunition detonation, and the burning hulk that marked another Sherman kill. Horvath acquired the Tiger through his telescopic sight at the same moment. His loader had already positioned an M93 round, recognizable by its silver band and lighter weight compared to standard ammunition. The hypervelocity round seated differently in the gun's breech, producing a distinctive metallic click that Horvath's crew had learned to associate with their most powerful weapon. The gunnery problem Horvath faced required calculations that exceeded his formal training. M93 rounds traveled at velocities approximately 30% higher than standard ammunition, requiring different elevation settings for the same target range. The tungsten core's lighter weight made the projectile more susceptible to wind drift, demanding compensation that Horvath had to estimate based on limited training experience. But Horvath possessed one crucial advantage that German tank doctrine had never anticipated: the ability to engage heavy armor at ranges where Tigers assumed themselves invulnerable to American fire. German crews positioned their tanks to maximize protection against weapons they expected to face. The threat of penetration from a Sherman at 800 yards simply didn't exist in Wehrmacht tactical calculations. Horvath fired before Dietrich's gunner completed his own firing solution. The M93 round left the 75mm barrel at approximately 2,600 feet per second, substantially faster than the 2,000 feet per second achieved by standard ammunition. The aluminum jacket stripped away during flight, leaving the tungsten carbide core to continue toward the Tiger at velocities that concentrated tremendous kinetic energy into the projectile's 1-inch diameter. The core struck the Tiger's frontal armor at an angle that would have deflected standard American ammunition. Face-hardened steel designed to shatter conventional penetrators proved inadequate against tungsten carbide traveling at hypervelocity. The core punched through 100 millimeters of armor plate, penetrating into the Tiger's fighting compartment, where it fragmented violently, sending tungsten and steel shrapnel through the crew space. Dietrich's gunner died instantly as shrapnel severed his carotid artery. The driver sustained wounds that would prove fatal within hours. Dietrich himself suffered severe lacerations, but remained conscious long enough to order his surviving crew to abandon the tank. The Tiger sat immobilized, its gun silent, penetrated by a weapon that German intelligence had declared incapable of threatening heavy armor at such ranges. The second Tiger, positioned 50 yards behind Dietrich's vehicle, attempted to identify the source of the unexpected attack. The crew had witnessed their lead tank's destruction, but struggled to comprehend what weapon could have achieved penetration from 800 yards. German tactical doctrine provided no framework for understanding Sherman guns that could defeat Tiger armor at such distances. Horvath's loader positioned another M93 round while the gunner acquired the second Tiger through his sight. The tactical situation had transformed in ways that favored American gunnery. German crews expected to engage at ranges where their armor provided protection. The reality of facing penetrating fire from distances they considered safe created hesitation that proved fatal. Horvath's second shot struck the Tiger's turret face, achieving penetration that killed the commander and gunner while disabling the main gun. The surviving crew members abandoned their tank within seconds, leaving 2 Tigers destroyed or disabled by a weapon system that shouldn't have posed any threat at the engagement range. German radio intercepts from the engagement revealed confusion that would characterize Wehrmacht responses to M93 ammunition throughout the Italian campaign. Tank commanders reported facing unexpectedly effective American fire at ranges where Sherman guns should have been harmless. Some reports suggested that Americans had deployed new tank variants with upgraded weapons. Others theorized that British 17-pounder guns had been mounted on Sherman chassis without German intelligence detecting the modifications. None of the German reports identified the actual source of improved American penetration. The tungsten-cored ammunition that had defeated Tiger armor remained invisible to German analysis. Spent M93 casings recovered from American positions looked identical to standard 75mm casings. The tungsten core had fragmented on penetration, leaving no intact evidence that German metallurgists could examine. The intelligence failure extended to the highest levels of German tank production and tactical development. Wehrmacht situation reports continued to cite American 75mm guns as ineffective against heavy armor beyond 500 yards. German tank crews received tactical instruction based on assumptions that had become obsolete the moment M93 ammunition reached combat units. American operational security surrounding the special ammunition proved remarkably effective throughout the Italian campaign. Tank crews followed strict protocols for recovering spent casings and avoiding discussion of ammunition performance. The silver band that identified M93 rounds became known among American tankers as the Tiger Stripe, a private designation that never appeared in official communications where German intelligence might intercept it. Horvath's after-action report, carefully sanitized to remove references to special ammunition, described engaging German heavy armor at extended range with successful results. The report provided no technical details about ammunition type or penetration performance. Horvath himself received no special recognition for the engagement. The institutional priorities that governed M93 deployment emphasized security over publicity. The strategic implications of improved American armor-piercing capability extended beyond individual tank engagements to affect the overall calculus of armored warfare in Italy. German tank commanders had to reconsider their tactical assumptions about engagement ranges and armor protection. The comfortable certainty that Tiger armor provided immunity from American fire at distances beyond 500 yards had been shattered by weapons that German intelligence couldn't identify or explain. As February turned to March and the Anzio stalemate continued, reports of unexpectedly effective American tank fire accumulated in German intelligence files. The pattern was consistent: Sherman tanks achieving penetrations at ranges where standard 75mm guns should have been ineffective. Tiger crews reporting losses to weapons they couldn't identify. Tactical situations where German armor advantages failed to materialize as doctrine predicted. German responses to these anomalies revealed the limitations of intelligence analysis, constrained by assumptions about enemy capabilities. Wehrmacht analysts examined multiple hypotheses: Americans deploying undetected weapon upgrades, British sharing advanced ammunition technology, changes in American armor-piercing round composition. None of the analyses identified tungsten-cored, sub-caliber ammunition as the source of improved performance. The analytical failure stemmed partly from German understanding of American industrial capabilities. German metallurgists knew that tungsten carbide technology required sophisticated manufacturing processes and scarce raw materials. The assumption that Americans couldn't produce such ammunition in tactically significant quantities led German analysts to dismiss the possibility without serious investigation. This intelligence failure created systematic disadvantages for German armored forces throughout the spring of 1944. Tactical doctrine, based on incorrect assumptions about American gun performance, led to positioning and maneuver decisions that exposed German tanks to effective fire at ranges they considered safe. The cumulative effect appeared in casualty statistics, showing higher than expected German armor losses to Sherman fire. Horvath's crew gained confidence from their successful engagement with special ammunition, but they also learned the limitations that governed M93 employment. Each tank carried only 10 rounds of the precious tungsten-cored ammunition. Once expended, crews reverted to standard rounds with all their performance limitations against heavy armor. The scarcity created tactical pressure to conserve M93 rounds for situations where they were absolutely essential. The psychological impact of possessing weapons that exceeded enemy expectations proved as significant as the technical performance improvement. American tank crews operating with M93 ammunition approached engagements with confidence that had been absent during earlier encounters with German heavy armor. The knowledge that their guns could penetrate Tiger armor at extended range altered crew behavior and tactical decision-making in ways that enhanced overall combat effectiveness. As the Italian campaign ground through its brutal spring offensive, the gap between German intelligence estimates and American tactical capabilities continued widening. German forces adapted their tactics based on what they believed about American weapons, while American crews exploited capabilities that German analysts refused to credit as possible. The quiet revolution in armor-piercing technology had created an invisible advantage that would persist until German intelligence finally identified the source of American improvements, or the war ended with German defeat. The ammunition scarcity that governed M93 deployment created a two-tier system within American armored units. Crews with remaining hypervelocity rounds could engage German heavy armor with reasonable confidence at ranges approaching 1,000 yards. Crews who had exhausted their M93 allocation reverted to the desperate tactical situation that had characterized earlier American operations against Tigers and Panthers. Lieutenant James Morrison commanded a Sherman platoon in the 34th Infantry Division during the spring offensive toward Rome. His own tank retained 6 M93 rounds, carefully hoarded for encounters with German heavy armor. 2 other tanks in his platoon had exhausted their special ammunition during previous engagements, leaving them dependent on standard rounds that required closing to suicidal ranges for effective penetration. The tactical disparity created complex command decisions. Morrison had to balance the advantage of engaging with M93 ammunition against the responsibility of supporting tanks that lacked similar capabilities. German forces couldn't distinguish which American tanks carried hypervelocity rounds, but Morrison's crews understood the difference between possessing weapons that could defeat heavy armor and operating with guns that German intelligence correctly assessed as inadequate beyond 500 yards. The spring fighting around the Gustav Line demonstrated both the power and the limitations of tungsten-cored ammunition. American tank units achieved penetrations against German heavy armor at ranges that shocked Wehrmacht crews while struggling with ammunition shortages that prevented sustained engagement. The M93 rounds that had seemed so plentiful during initial issue disappeared rapidly under combat conditions where every encounter with Tigers or Panthers justified expenditure of scarce hypervelocity ammunition. Ordnance Department planners, wrestling with tungsten allocation, faced impossible choices. Machine tool production, essential for manufacturing everything from aircraft engines to artillery pieces, required tungsten carbide cutting tools. Tank ammunition competed with industrial priorities that affected the entire war production apparatus. The compromise solution provided limited M93 allocation to armored units while preserving tungsten supplies for critical manufacturing applications. Staff Sergeant Robert Hayes, now a veteran of dozens of engagements, learned to ration his remaining M93 rounds with the care of a miser counting gold. Each hypervelocity projectile represented potential survival against German heavy armor. Hayes maintained detailed mental accounting of his ammunition status, knowing exactly how many M93 rounds remained and calculating whether each tactical situation justified their expenditure. The psychological burden of ammunition rationing affected crew performance in ways that training had never anticipated. Gunners had to make split-second decisions about whether targets justified use of scarce hypervelocity rounds or could be engaged with standard ammunition. The pressure of these decisions under combat stress led to situations where crews either wasted precious M93 rounds on inappropriate targets or conserved ammunition while facing threats that justified its use. German intelligence services continued struggling to identify the source of improved American tank gun performance throughout the spring campaign. Captured American tanks showed no modifications to guns or ammunition storage that would explain enhanced penetration. Interrogated American prisoners, carefully instructed to provide no information about special ammunition, maintained cover stories about improved training and tactics rather than upgraded weapons. The security measures surrounding M93 deployment created an intelligence vacuum that German analysts filled with increasingly elaborate theories. Some reports suggested Americans had secretly upgraded their armor-piercing round composition without changing external appearance. Others proposed that American crews had developed superior gunnery techniques that maximized penetration from standard ammunition. The actual explanation, tungsten-cored subcaliber projectiles, remained invisible to German analysis, constrained by assumptions about American industrial capabilities. By June 1944, as Allied forces prepared for the Normandy invasion, American armored units in Italy had accumulated 6 months of combat experience with M93 ammunition. The tactical lessons learned shaped doctrine that would govern hypervelocity round employment throughout the European campaign. Engage heavy armor at maximum effective range. Fire M93 rounds, first to achieve penetration. Conserve ammunition for situations where standard rounds proved inadequate. Never discuss ammunition performance or capabilities with anyone outside the immediate crew. The fall of Rome in June brought American tank units into more open terrain, where engagement ranges increased and German heavy armor could employ its tactical advantages more effectively. The changed battlefield conditions made M93 ammunition even more valuable, as the distances where hypervelocity rounds could penetrate Tiger armor exceeded the ranges where standard ammunition achieved reliable penetration. Sergeant Michael Horvath, promoted after his successful February engagement, commanded his own tank by summer 1944. His crew had developed procedures for employing M93 ammunition that reflected hard-won combat experience. The loader kept hypervelocity rounds positioned for immediate access. The gunner maintained separate range cards for M93 and standard ammunition, accounting for the different ballistic properties. The commander tracked ammunition expenditure with obsessive precision, ensuring that precious tungsten-cored rounds remained available for encounters with heavy armor. German tank production continued throughout 1944 without incorporating any responses to American hypervelocity ammunition because German intelligence had never identified the threat. Tiger and Panther tanks rolled off production lines with the same armor configurations that had proven adequate against early American 75mm rounds. The face-hardened steel that shattered standard penetrators remained vulnerable to tungsten carbide cores, traveling at velocities that concentrated tremendous energy into minimal impact areas. The intelligence failure created systematic vulnerabilities that American crews exploited throughout the Italian campaign's final phase. German tanks positioned to maximize protection against expected American weapons found themselves penetrated by fire from ranges they considered safe. Tactical doctrine, based on incorrect assumptions about enemy capabilities, led to positioning decisions that exposed German armor to effective American fire. As summer advanced and Allied forces pushed north toward the Gothic Line, the cumulative impact of M93 ammunition appeared in German casualty statistics. Tiger and Panther losses to American tank fire exceeded what German doctrine predicted based on Sherman gun capabilities. The discrepancy between expected and actual loss rates forced German tactical revisions without German intelligence understanding why their armor advantages had diminished. The human dimension of ammunition scarcity became apparent as crews rotated back to rear areas after extended combat deployments. Tank gunners described the psychological pressure of engaging German heavy armor with limited supplies of ammunition that could defeat it. Loaders recounted the stress of managing mixed ammunition loads where hypervelocity and standard rounds required instant identification under combat conditions. Commanders reported the burden of making real-time decisions about whether tactical situations justified expenditure of irreplaceable tungsten-cord projectiles. The Ordnance Department's post-campaign analysis revealed that American tank units in Italy had achieved penetration rates against German heavy armor that exceeded pre-deployment predictions by substantial margins. The success stemmed directly from M93 ammunition capabilities combined with operational security that prevented German forces from adapting their tactics to counter the threat. The invisible advantage had proven decisive in armored engagements throughout the campaign. As preparations accelerated for expanded operations in Northern Europe, the lessons learned in Italy shaped ammunition allocation and tactical doctrine for the massive armored formations that would participate in the liberation of France and the advance into Germany. The tungsten cord ammunition that had transformed American 75mm guns from inadequate weapons into tiger killers would accompany armored divisions across the beaches of Normandy and into the battles that would determine the war's outcome. The Normandy invasion brought American armored divisions equipped with M93 ammunition into the most intensive tank combat of the European War. The hedgerow country of the Bocage provided German defenders with ideal terrain for employing heavy armor in defensive ambush positions where Tigers and Panthers could engage at close range before American forces could maneuver for flank shots. Staff Sergeant Robert Hayes landed at Utah Beach in late June 1944 with the 1st Armored Division carrying 12 M93 rounds carefully secured in his Sherman's ammunition storage. The allocation had increased from the original 10 rounds per tank as tungsten supplies improved and Ordnance Department planners recognized the ammunition's tactical value. Hayes and his crew had received updated briefing on employment doctrine refined by combat experience in Italy. The tactical environment in Normandy differed dramatically from the relatively open terrain of the Italian campaign. Engagement ranges rarely exceeded 500 yards in the maze of hedgerows and narrow roads that characterized the French countryside. German heavy tanks, positioned in concealed firing locations, could achieve first-shot advantage against American armor, attempting to advance through terrain that channeled movement into predictable routes. But the close engagement ranges that favored German defensive tactics also brought American guns into the envelope, where even standard 75mm ammunition could achieve penetration against Tiger side armor and Panther turret faces. M93 rounds provided capability to defeat frontal armor at ranges where German crews expected immunity from American fire, but the tactical situations in Normandy often prevented American tanks from achieving firing positions where hypervelocity ammunition's range advantage became decisive. Hayes first employed his M93 ammunition during fighting near St. Lo in mid-July. His platoon had been tasked with supporting infantry attacks against German positions anchored by at least 2 Tiger tanks positioned to command the approaches to a strategically important road junction. The Tigers occupied hold-down positions that maximized armor protection while providing clear fields of fire across approximately 600 yards of open ground. The tactical problem Hayes faced required using M93 ammunition, not for its range advantage, but for its ability to penetrate frontal armor that would deflect standard rounds. His gunner acquired the first Tiger through the sight at 580 yards, well within effective range for hypervelocity penetration, but at a distance where the Tiger's 88mm gun could destroy the Sherman with equal certainty. Hayes fired first, his M93 round striking the Tiger's glacis plate at an angle that would have deflected standard ammunition. The tungsten carbide core penetrated, killing the driver and setting off a secondary explosion that disabled the tank. The engagement lasted less than 10 seconds from first shot to Tiger destruction, but demonstrated how hypervelocity ammunition had transformed the tactical calculus of American armor facing German heavy tanks. The second Tiger attempted to engage Hayes's position, but was struck by M93 fire from another Sherman in the platoon before achieving effective firing solution. German after-action reports from the engagement revealed the confusion that American hypervelocity ammunition continued creating among Wehrmacht tank crews, Tigers destroyed by frontal penetration at ranges where German doctrine insisted American guns were ineffective. Tactical situations where German armor advantages disappeared against weapons that intelligence assessments had thoroughly analyzed and dismissed. German responses to unexpectedly effective American tank fire evolved throughout the summer campaign in France. Some Wehrmacht units began employing more cautious tactics, avoiding engagement ranges where American guns had proven capable of achieving penetration. Others adapted positioning to maximize armor protection against what they assumed were upgraded American weapons. None of the German tactical modifications addressed the actual source of improved American performance because German intelligence had still not identified tungsten-cored ammunition as the explanation. The security measures surrounding M93 deployment remained rigorous throughout the Normandy campaign. Tank crews recovered spent casings when tactically feasible. Orders prohibited discussion of ammunition performance in any communication that might be intercepted. Even unit after action reports used carefully sanitized language that described successful engagements without technical details about ammunition types employed. The operational security proved remarkably effective. German intelligence documents captured during the rapid advance across France in August showed continuing uncertainty about American tank capabilities. Reports described Sherman guns achieving unexpected penetrations, but attributed the results to factors ranging from crew training to undocumented weapon modifications. The tungsten carbide cores that actually made penetration possible remained invisible to German analysis. As Allied forces broke out of the Normandy lodgment and began the pursuit across France, engagement ranges increased and the tactical environment became more fluid. American armor could maneuver for advantageous firing positions rather than attacking prepared German defensive positions. The changed battlefield conditions made M93 ammunition's range advantage increasingly valuable, as American crews could engage German heavy tanks at distances approaching 1,000 yards. Lieutenant James Morrison, now commanding a tank company in the 3rd Armored Division, participated in the liberation of Paris and the subsequent pursuit toward the German frontier. His unit had been allocated additional M93 ammunition as production increased and tungsten supplies improved. Morrison's tanks carried between 15 and 20 hypervelocity rounds each, providing substantially more capability than the limited allocations of earlier months. The increased ammunition supply allowed American crews to employ M93 rounds more liberally, engaging German armor at extended ranges without the desperate ammunition conservation that had characterized earlier operations. Tank gunners could fire multiple hypervelocity rounds at difficult targets rather than rationing single shots for only the most critical situations. The tactical flexibility that adequate ammunition supplies provided enhanced American effectiveness against German heavy armor throughout the pursuit across France. German forces retreating toward their frontier left behind destroyed equipment that told the story of a collapsing defensive system. American recovery teams examining knocked-out Tiger and Panther tanks found penetrations through frontal armor that German metallurgists had assumed immune to American 75mm fire. The physical evidence contradicted intelligence assessments that continued to insist American medium-velocity guns posed no threat to heavy armor at extended ranges. But German technical intelligence services examining the evidence struggled to identify the mechanism that had achieved such penetrations. Tungsten carbide cores fragmented on impact, leaving no intact evidence for metallurgical analysis. American operational security prevented capture of intact M93 rounds or spent casings that might reveal the ammunition's composition. The intelligence vacuum persisted even as battlefield evidence mounted that American tank guns had somehow evolved beyond what German doctrine assumed possible. The autumn fighting in the Hürtgen Forest and along the German frontier brought American armored units into close-quarters combat where M93 ammunition's advantages became less decisive. Heavy forest and urban terrain limited engagement ranges to distances where even standard ammunition could achieve penetration against German armor side shots. The hypervelocity rounds remained valuable for frontal engagements, but provided less tactical advantage than they had in the more open terrain of France. Sergeant Michael Horvath's crew, now veterans of 8 months' continuous combat, had developed sophisticated procedures for employing their mixed ammunition loads. The gunner maintained range cards that specified which ammunition type to use at various distances against different German armor types. The loader could identify M93 rounds instantly by touch in complete darkness, ensuring that hypervelocity ammunition was available when the tactical situation demanded it. The commander tracked expenditure and carefully rationed remaining stocks to ensure critical engagements could be supported with appropriate firepower. As 1944 ended and Allied forces prepared for final offensives into Germany, the M93 ammunition that had transformed American 75mm guns from inadequate weapons into capable heavy armor killers had achieved tactical success that exceeded every initial projection. German intelligence had never identified the source of improved American penetration. German tactical doctrine remained based on assumptions about American gun performance that had become obsolete when tungsten-cored ammunition reached combat units. The invisible advantage persisted through operational security that prevented German forces from adapting to capabilities they refused to believe Americans possessed. The final American offensive into Germany in early 1945 brought M93 equipped Sherman tanks into combat against the last German armored reserves defending their homeland. By this stage of the war, American ammunition supplies had improved to the point where most tanks carried 20 to 25 hypervelocity rounds, providing substantial capability for engaging the Tigers, Panthers, and New King Tiger tanks that German forces deployed in desperate defensive operations. Staff Sergeant Robert Hayes crossed the Rhine in March 1945 with his crew, veteran survivors of nearly a year of continuous combat. Their Sherman carried 23 M93 rounds, along with a full load of standard ammunition and high-explosive shells. The hypervelocity ammunition that had once seemed so precious had become routine equipment, still carefully employed but no longer rationed with the desperate conservation of earlier campaigns. The tactical environment inside Germany favored American armored operations despite continued German resistance. Allied air superiority prevented German forces from maneuvering heavy armor effectively. Fuel shortages immobilized German tanks that might have posed serious threats. The overall collapse of German logistics meant that even formidable weapons, like the King Tiger, often sat disabled for lack of supplies rather than destroyed by enemy fire. But where German armor did engage, M93 ammunition continued providing American crews with capabilities that German intelligence had still not properly identified. Hayes participated in engagements where his hypervelocity rounds penetrated King Tiger frontal armor at ranges exceeding 800 yards, achieving kills against the most heavily armored production tank of the war using a gun that German doctrine insisted was ineffective against heavy armor. German prisoners, interrogated about their experiences fighting American armor, described the psychological impact of facing penetrating fire from weapons they had been trained to dismiss as inadequate. Tiger and Panther crews reported approaching engagements with American Shermans only to find their armor defeated by fire from ranges where German tactical doctrine insisted they were safe. The cumulative effect eroded German confidence in the armor protection that had provided psychological as well as physical advantages throughout the war. American intelligence services examining captured German documents in the war's final months discovered the extent of German analytical failure regarding American ammunition. Wehrmacht situation. Reports from as late as April 1945 continued to describe American 75mm guns as ineffective against heavy armor beyond 500 yards. German training manuals issued in early 1945 instructed tank crews on tactics for engaging Sherman tanks based on assumptions about American gun performance that had been obsolete since M93 ammunition reached combat units in early 1944. The intelligence failure extended to German tank design and production. Panthers and Tigers manufactured in the war's final months retained the same armor configurations that had proven vulnerable to tungsten-cored ammunition. German metallurgists made no modifications to address penetrations they couldn't explain because their intelligence services had never identified the threat that needed countering. As German resistance collapsed in May 1945, the final statistics on M93 ammunition employment became available to Ordnance Department analysts. American tank units had fired approximately 42,000 hypervelocity rounds during combat operations in Europe. The ammunition had achieved penetration rates against German heavy armor exceeding 70% when employed within its effective range envelope. German forces had never adapted their tactics or equipment to counter the threat because German intelligence had failed to identify what made American gun performance improve so dramatically. Lieutenant Colonel Leslie McNair, who had witnessed the first disappointing tests of standard ammunition against Tiger armor in 1942, visited Germany in June 1945 to examine knocked-out German tanks. He found Panthers and King Tigers with frontal penetrations that German metallurgy had assumed impossible from American medium-velocity guns. The physical evidence validated every calculation that had justified M93 development and production. Sergeant Michael Horvath returned to the United States in July 1945, his combat service complete. He had fired 87 M93 rounds during his combat tour, achieving documented penetrations against 13 German heavy tanks that would have been invulnerable to standard ammunition at the engagement ranges involved. The hypervelocity ammunition had transformed his 75mm gun from an inadequate weapon into a tiger killer capable of defeating the most heavily armored opponents at ranges approaching 1,000 yards. The post-war analysis of M93 ammunition effectiveness revealed that American tungsten cord rounds had achieved tactical success through a combination of superior technology and operational security that prevented enemy adaptation. German forces had fought throughout the final 2 years of the war with tactical doctrine based on incorrect assumptions about American capabilities. The intelligence failure had cost German armored forces dearly in situations where better information might have led to tactical modifications that reduced vulnerability. American production statistics showed that approximately 115,000 M93 rounds had been manufactured during the war, despite severe tungsten shortages that limited output throughout the production period. The scarcity had forced careful allocation and employment discipline, but had not prevented enough ammunition reaching combat units to achieve decisive tactical impact where American armor engaged German heavy tanks. The human cost of the ammunition's success was measured in American tank crews who survived engagements they would have lost with standard weapons. Hayes, Horvath, Morrison, and thousands of other tank crewmen returned home because their guns could penetrate German armor at ranges where enemy crews assumed American fire was harmless. The tungsten carbide cores that made those penetrations possible had saved American lives while killing German tank crews who died without understanding what weapon had defeated armor they believed invulnerable to American guns. The German perspective on American tank capabilities evolved slowly even after the war ended. Captured German engineers interviewed by American technical intelligence teams expressed genuine surprise when shown M93 ammunition and informed of its performance characteristics. Some German metallurgists initially refused to believe that American industry could produce tungsten cord projectiles in tactically significant quantities given the material scarcity and manufacturing challenges involved. The final vindication of M93 development came in official U.S. Army studies published in 1946 analyzing tank combat effectiveness in the European theater. The reports credited tungsten cord ammunition with transforming American 75mm guns from weapons inadequate against German heavy armor into capable tank killers, effective at tactically decisive ranges. The modification had not required redesigning tanks or developing new guns, only applying industrial chemistry and metallurgy to create ammunition that exceeded every performance parameter of standard rounds. Lieutenant Colonel McNair retired from military service in 1946, his contribution to American armor effectiveness largely unknown outside the Ordnance Department and affected combat units. The security classifications surrounding M93 ammunition persisted into the Cold War, preventing public discussion of the technology that had given American tank crews invisible advantages against German heavy armor. The memorial service for the tank crews who had died fighting German armor was held at Arlington National Cemetery in November 1946. Among the attendees were veterans who had survived because their guns could penetrate Tiger armor at 800 yards, a capability that German intelligence had dismissed as impossible and German tactical doctrine had never anticipated. The legacy of M93 ammunition extended beyond its immediate tactical impact to influence post-war American tank gun development. The principle of using sub-caliber tungsten penetrators became standard in American armor-piercing ammunition design, leading to increasingly sophisticated projectiles that continued the revolution begun by those first hypervelocity rounds issued to combat units in early 1944. German tank crews who survived the war and later learned about American tungsten-cored ammunition expressed the frustration of having fought against an enemy capability their own intelligence services had never properly identified. The analytical failure had shaped tactical doctrine that exposed German armor to threats that better intelligence might have revealed and countered. The quiet revolution in American armor-piercing technology had succeeded through careful industrial development, stringent operational security, and German intelligence failures that prevented enemy adaptation to capabilities that transformed American tank guns from inadequate weapons into Tiger killers effective at ranges approaching 1,000 yards. The transformation had been invisible to enemy observation, unknown to most Allied personnel, and decisive in countless engagements where American crews survived because their ammunition could penetrate armor that German doctrine insisted was immune to their fire. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.